What was that? Okay. What angle has a cosine of x, whatever we want to find that cosine of? We talked a little bit ago, we also have to go back and we have to restrict the domain of cosine. We have to restrict the domain to make it 1 to 1. Unlike sine, you can actually get both all the positive and negative values from 0 to pi. So the domain for cosine, we restrict the domain to 0 to pi. And as always, that gives us a range of -1 to 1. So cosine inverse, or arc cosine, will then have a domain of -1 to 1. In other words, that's the numbers you could actually get an angle that has a sine of. And its range will be 0 to pi. So before, like that very last one on the quiz, it was 3 pi over 2, but that's not in the domain of sine inverse or arc sine. Negative pi over 2 is. That's why negative pi over 2 is that answer. With this one, all of them will either be in the first or the second quadrant. And of course, as always, if I'm going too fast, just let me know. But let us take a look at example numero uno. Let's go for the arc cosine of the sine of 3 pi over 4. Pastorello?
Are you serious? No, you realize you acting that way makes it fun.
So all the guilty people said, no, I was never there. Okay, so question, a Doug question, but let's go back. What do we do first, the inside or the outside of the parentheses? Inside. Do things cancel out? Not necessarily, and I hate to ever assume that things cancel out, so let's just figure out what they are. The sine of 3 pi over 4. 3 pi over 4 is how many degrees? 135, right? Pi over 2 is 90. 3 pi over 2 would be 135. The sine of 135 is square root of 2 over 2. Let's say that again. Sine of 3 pi over 2, square root of 2 over 2. Is it positive or negative? Positive, right. So we got the arc cosine of the square root of 2 over 2. Now remember, cosine is positive in the first quadrant, negative in the second quadrant, because we're talking about x values now, and they are negative to the left. So what angle gives you a cosine of square root of 2 over 2? Pi over 4, right. Okay, that's a pretty easy one. Want another easy one, or are you ready to do a hard one?
Hard one.
Okay, now here's where things get tricky. So then you walk into the dark alley and you get something like this. So, and in fact, I feel bad because I saw several of you just take out that memory sheet, and now we're going to do the ones that aren't on the memory sheet. So let's look at example 2. Let us say we're in a dark alley and we have to find the tangent of the, yep. We have to find the tangent of the, there we go, of the arc cosine of 2/3. And you say to yourself, wait a minute, 2/3 wasn't on the sheet. What do I do now? Bad news. You can't use a calculator on this one. I know, some people's children, I know. Talk to the person sitting next to you. Ideas on what we could do to therefore figure that one out. Ideas on what we could do to figure that one out. And don't say look at your memory sheet, because it's not on there now. Memory sheet. Get a new memory sheet. You don't want to have to memorize all the numbers you have to get to the 2/3.
I would memorize it.
Run away from the guy in the dark alley. Hope it's not a dark alley. Anybody got ideas? What can we do? Hayden, what can we do?
Randall said solve for the angle.
Solve for the angle. How would we figure out the angle? Oh, what? If we set up a what? We set up a We set up a triangle, because remember, at the end of the day, all of these are ratios of vertical, horizontal, and total distance. We set up a triangle because there is some angle that has a cosine of 2/3. We don't know what that angle is, so let's just call it x for now, because that's what we call things in math we don't know. Cosine is the 1 over the what? Vertical, horizontal, total. Where does 2 and 3 go? It's the horizontal over the total, right. So horizontal would be our 2, total would be our 3. Okay, so there is some angle that has a cosine of 2/3. We don't know what it is, it's called x, but we don't actually have to figure out what that angle is. We just have to figure out what its what is. We don't actually have to figure out what the angle is. And that's what most people miss in this. They feel like I have to figure out what x is. It's kind of weird. You actually don't have to figure out what x is. I don't have to find the angle. I have to find that angle's what? Tangent. Right, I have to find the tangent of that angle. The tangent is the what over the what? Opposite over the adjacent, or the vertical over the horizontal. Right. So either way, we have to find out what measurement. We have to find out what measurement. Yeah, vertical. How do we figure that out? Pythagorean theorem. This is right triangle. Right on. Figure that out real quick. Before you go crazy, though, what's the hypotenuse of this one? 3. Right. Remember, 2 and 3 are not the two side lengths. 3 is the hypotenuse. 2 is one of the side lengths. There's 2 errors people make on this to make it really hard, because this isn't really that hard a section. The hard part we've already covered, which is the understanding that it has to be 1-to-1, and we have to restrict the domain to make it 1-to-1. The easy part is actually these problems, because they really end up feeling a lot simpler than they are. The 2 mistakes people make is, number 1, they feel like they have to find out what that angle is when you don't actually have to know what this angle is. You just have to know what its tangent is, and you can figure that out without knowing the angle. And number 2, they forget that the 3 is not a side, it's the hypotenuse of it. Okay, stop and check it. There's the math on that. That's the easy part. You probably got the square root of 5. Question to you. Every time I take the square root, I have to think about what? Okay, this is not an exception to that rule. You do have to go right here and you have to consider the plus or minus. You have to consider the plus or minus. How do we know if it's positive or negative? I drew it positive, possibly to deceive you, but I drew it positive. How can we know for sure if it's positive or negative? How can we know for sure? Talk to the person sitting next to you. How can we know for sure if it's positive or negative? How can we know for sure if it's positive or negative? What's that? Equals? No. So why the heck will I get know that? Because Cassie Bullock? Yeah. Because you guys live on the north. You guys live way on the north part of the district. And on Twitter, he did thank the students for the advice. He signed their death. He basically put it in. Yeah, he threw them under the bus. Thank you. Here are the 3 students. I saw that cancel school. I saw that immediately. Do any of them go here? Okay, that's good for their health. Okay, and this is again, and this is an honors class, so we do present opportunities for you to understand if you should be a math major. And I'm sure the first day you probably should this out, but my job is to make you math majors, even if you don't realize you're not right now. But this is a question you have to understand why we're doing this. Can we determine for sure if the vertical distance is positive or negative? If so, how can we do it? How can we say for sure that it should be a plus or a minus, or is it conditional? Anybody got an idea? Is it positive, is it negative, or is it conditional? In other words, you can't tell for sure, then you have to think about it every time.
It has to fit between 0 and pi.
It has to fit in between 0 and pi, right? Because what is the range, aka the answers of our cosine? Our cosine will give us answers that are between what? 0 and pi. Why does that matter? Mackenzie? Why will it make it positive? Well, the vertical distance, and remember, this is why at the start of the year, at the start of this year, I did tell you, your teachers really do you a disservice of this type of question because they really limit the ceiling of what you can learn because they say opposite and adjacent, when in reality it's really not an opposite and adjacent measurement. It's a vertical measurement and a horizontal measurement. There's no ceiling at what you can learn when you think of it that way. When you think of opposite and adjacent, then you're like, well, why would you care about that? Opposite could be any number, right? But vertical can't be. Vertical now has something that is associated with it because you're going up or you're going down like an airplane. There's a big difference between taking off and taking down. You in the newspaper. One of them gets you in the newspaper, one of them nobody knows who you are. Mackenzie, why is 0 and pi relevant to a discussion on the vertical height? Why does it have to be positive? You're right, it has to be positive between 0 and pi. Why? You're shifted to the domain, but why does 0 and pi make it always positive? Stefan?
It's not a range.
It's not a range. Okay, take out your axis real quick. Take out your hands. Actually, physically participate. You can visually learn this. So take it out. Okay, so imagine you're taking out your little cannon. You're pointing it straight at the enemy. Okay, and you turn it so many degrees. Straight at the enemy. You point it at that. Okay. So you pointed a certain number of degrees. Now, I would like you to check out every measurement between 0 and pi. What's true about all of their vertical measurements between 0 and pi? They're all positive because it's always going up, right? Even if you go back and you're now shooting it yourself, it's still going up in the air. Anywhere between 0 and pi. So when you take arc cosine, you're going to get an answer between 0 and pi. And we know for sure between 0 and pi that vertical distance is going to be positive. So we always have to consider and have that discussion on, is it going to be positive or negative? Because that is an application of the square root that we have to take advantage of here. When we take the arc cosine, it's always positive. If you take arc sine, that's not necessarily true because arc sine goes from negative pi over 2 to pi over 2. What measurement is always positive between 0 or between negative pi over 2 and pi over 2? What measurement, vertical, horizontal, or total, is always positive between negative pi over 2 and pi over 2? Horizontal, right. Which notice, if you had an arc sine problem, you would take the sine inverse. What would you be missing? You'd be missing the horizontal measurement, which you now know is always positive because anywhere between negative pi over 2 and pi over 2 is positive. Tangent, you have to consider it. Tangent, there's no steadfast rule we can always apply. You have to consider it on a case-by-case basis. That's the kind of thing math majors think about, though. Questions on that? Yep.
Okay, I was kind of confused.
Yep.
Okay, so you said what measurement is always positive between negative pi over 2 and
Yep.
pi over 2?
Horizontal, vertical, or total?
Okay.
Which one is?
Vertical.
Nope.
Horizontal.
Because pi over 2, remember, starts down here. And think of your cannon. It's pointing down now, so it's going to fire downward. But as you rotate between negative pi over 2 to pi over 2, always going positive, going away from you.
Okay. Okay.
Notice you even use the right word, she saw it. That's something you probably have to see to be able to understand why it's always true. It's always going to be pointing away from you. So it's a positive horizontal distance. Other questions? Also notice another thing too, because when you all are high school math teachers, like I'm trying to convince you to be, because you're going to be a teacher, you might as well teach math. Notice how long it took me to wait for her to ask that question? You have to wait for questions. If people are learning something for the first time, you have to give them time to think about how to ask the question. That's right, Bernie. That's right, Bernie. I can't wait to see Colin Bernie's resume flying across the, yeah, that's what I would say in high school too. Why would you see him in the paper?
No, I'm saying
I haven't had a student yet from DCC with a senior picture to put on that particular wall, so. There is a student who graduated from the class of 2008 that was in 2009 was in jail for murder. So some people don't wait a long time to do that. Hannah. No, there's a different wall. I haven't put that wall up here yet. It's somewhere in that stack over there. Because that's the class of 2008, class of 2009. There's a stack of class of 2010, 11, 12. And then I have a stack of students who I have a senior picture of who have been convicted of murder.
how come theirs?
Theirs, it's a special wall. When I point to don't be that guy, that's really who I'm talking about. Yeah.
I thought you were talking about Nate. Now,
No, I like
it's
Nate.
totally different.
I like Nate, I just don't like him when he talks.
So when you compare me to be that guy, you're comparing me to a murderer?
I'm telling you not to be that guy. I've never said be that guy. That doesn't make any sense. Who am I talking about? Nate, Russell Wilson, Mr. Breebach? I don't know who we're talking about there. Okay, let's talk about tangent. That doesn't make, who are we talking about? It doesn't make any sense. Nobody knows who we're talking about. Yeah, but it's usually justified. Arctangent. Hannah, are you accusing me of discriminating because I don't say don't be that girl? Hannah. Hannah, if I say don't be that guy, everybody knows what I'm talking about. If I say don't be that girl, everybody's looking around the room and like, who are you talking about? Like,
Could say don't be that person.
gotta be political.
You're inferring that men are.
They
Exactly.
just don't learn as fast. It's
It's still sexist.
I'm sorry that Luke, I'm sorry that your brain doesn't mature as fast enough as a girl at the same age as yours. I say don't be 322. That's goodbye for life. Arctangent. Let's talk about the last one. Arctangent. Again, ask the same question. What angle has a tangent of x? What's that? Oh yeah, we didn't actually find the tangent. Thank you. Okay, so tangent then would be the opposite over the adjacent or the vertical over the hypotenuse, which would be the square root of 5 over 2, which would be our final answer. That's really as hard as the problems in this section get. The key thing you have to remember is, number one, if it is arctangent, you do have to consider if it's plus or minus because there's no guarantees with arctangent. And number two, you do have to consider and give away that you actually don't have to know the angle to be able to figure out what this problem is. Okay, let's talk about the last one, arctangent. Okay, this is, it's more complicated than the other two. Sine and cosine there, nice. Don't forget the tangent graph has a vertical asymptote at pi over 2, negative pi over 2. So it's kind of odd. If we look at tangent, let's specifically look at the range of tangent. What numbers could you get for an answer from a tangent? Like sine and cosine, the smallest number you get is -1. The biggest number you can get is +1. What about tangent? What's the smallest number you could get out for a tangent answer? Negative infinity, right? You can get any number. In fact, if you think about it, tangent is the ratio of vertical to horizontal. If you're pointing the gun almost perfectly up in the air, but just a little bit off, almost all the distance is going to vertical. So the ratio of vertical to horizontal is going to be huge. So we can go all the way from negative infinity to infinity. Tangent has an awkward domain, though. Because it has all these vertical asymptotes, you can plug in any number except which ones? Well, the vertical asymptotes, which are what? Where's tangent undefined at? That's on your memory sheet. Where's tangent undefined at? Pi over 2, 3 pi over 2. Yeah, all the multiples of pi over 2. So when we restrict the domain for this one, we just go between the first two. So it's kind of odd, but we restrict the domain to the same thing as we did for sine. One entire wave would happen between negative pi over 2 and pi over 2, so we restricted to that. So tangent inverse, the domain of tangent inverse is you can actually plug any number into tangent inverse. Like you can plug in the tangent inverse of 70,000. but the range you will get out is just negative pi over 2 to pi over 2. So just like sine only gives you, when you take the inverse sine to the arc sine, it only gives you numbers between negative pi over 2 and pi over 2. Tangent will do that same thing. Yep.
You can't plug that in.
Oh, thank you. That's a parenthesis. Stupid projector. Yep, that's a parenthesis, obviously. Other questions? Other questions? So kind of odd. You can plug any number into tangent inverse, so let us take a peek. Let us go for example 3 here. Let's go for the tangent of the tangent inverse of 5. The tangent of the tangent inverse of 5. Luke.
I do have a question.
Yep.
In all the other domains, it's the point that it can touch to the point that it can touch.
Yep.
Why in this domain is the point that it can't touch to the point that it
Because what is the tangent of pi over 2?
can fly?
Right, so you can't get an answer out for that, so it's everything in between. All the other ones, like when you plugged in sine of pi over 2, that's actually the number 1. When you plugged in sine of negative pi over 2, it's negative 1. But it's undefined if this has got a vertical asymptote, so you cannot get an answer when you plug those numbers in. And I'm actually going to change this one. Let's change it to an easier one. What's the tangent inverse of 2? Is that one on the memory sheet? Struggling for an easy one for tangent. It's an easy one for tangent. Oh, square root of 3. Let's go for that. Yeah, square root of 3. That'll be an easier one. Let's go for the tangent of the tangent inverse of the square root of 3. There we go. That's on the memory sheet. What was I thinking? 2. That's a cotangent one. Yep. Okay, so what angle gives you a tangent of square root of 3? Pi over 3, 60 degrees, right? And what's the tangent of pi over 3? What's the tangent of the square root of 3? What's the tangent of pi over 3? Do they cancel each other out all the time? No, they do not. They only cancel each other out if this number that you're taking the tangent of is between negative pi over 2 and pi over 2. If they are between that number, they cancel each other out. If they're not, they don't. That can be just coincidence. You can always talk yourself into the right answer.
If you had like something that was on the terminal angle of pi over 3, you just go back to it. Like, you just look for similar angles that in between.
But they would be coterminal, yes, but they wouldn't actually be equal. Because like if you plugged in 3 pi for the first one, you wouldn't get 3 pi out for the second one. They'd be coterminal, I agree, though. Okay, easy or hard one? Which one do you want? Let's go for the worst disaster you're going to run into tonight. As bad as this puppy's going to get. Let's go for sundown. Well, I'll take Sunday night. It's better than Monday night.
Monday night.
Monday night, you're going to be watching the college national championship game, but that's, I would do it on Sunday night. Okay, example 4. Let's go for, yep, let's make it nasty. Let's go for the cosine of the arctan yeah, 3x. So what if they don't even tell you what it is? Now they just give you a variable for it.
I don't even know where to begin.
Yeah, well, let's go back to what Randall told us. We should probably draw a what?
Triangle.
Triangle, yeah. So the angle with a tangent of 3x. And let's make it fun. Let's say x has to be greater than 0. That might not seem relevant right now, but it will be in a minute. The only thing that means is x is going to be what? Positive. Yeah, I have a feeling that's going to be important for us. Okay, so tangent of 3x. What's the denominator of 3x, even though we're too lazy to write it? 1, right. So we've got an angle whose tangent opposite over adjacent is 3x. So this would be 3x. This would be 1. Yeah, we should probably use a different variable. Let's call this y. Still in radians, not in degrees. But again, we don't actually have to find the angle to do that. How do we find its cosine?
Okay, so if that's 3x, then shouldn't the bottom side to be 1?
The bottom side is 1, yep.
It doesn't have to be 1.
No, because it's just denominator is just 1. Yeah, if it was 1x, then it'd just be 3, and then it wouldn't be so bad. Okay, ideas. How on earth do we find the radius or the hypotenuse? Oh, bad news. What did we use on the last one? Yeah, and we had the real satisfaction of getting a number for the answer, and what are we not going to get this time? The real satisfaction of getting an answer, or getting a number. We're just going to get a relationship. So we'll call this r the radius. So r squared is equal to 1 squared plus 3x. Quantity squared. Don't forget to square the x. Don't make it 9x. It's 9x squared. So r squared is equal to 1 plus 9x squared. Stop and check out questions on how to get there, and then we'll go further. It's messy, but it's not impossible. You just, and again, on this section, it's kind of like you have to give up on you have to know everything on this and just realize that you know enough to get what the answer is. Like you never find out what the angle is, but you can find out what its tangent is. I know, it is satisfying. Okay, what do you do to solve for r? Yeah, square it, square it. Okay, so r, what do you not have to forget on this? Yeah, plus or minus. So we'll talk about plus or minus. Okay, so then you can take the square root to get square root of 1 plus the square root of that, correct? Can you break up that square root?
Yeah. No.
No, because it's what? Addition, right. You cannot break up that square root, so it's not equal. That's as good as she gets because you can't take anything out. That's the only way you can simplify the square root. Is it positive or negative? 0. X is greater than 0. I heard some answers. I'm listening to see if there's any more. Arjun?
The vertical is positive and the horizontal is positive.
Okay, the vertical is positive, the horizontal is positive. What did we?
Hypotenuse must be positive.
So the hypotenuse must be positive, right on. The hypotenuse always has to be positive because it's a radius. The radius can't be negative. That's one that can never, your total distance from somewhere, if you said, hey guys, I met this awesome friend, he was about -4 miles from our house. No, the radius, the total distance can't ever be negative. So right, it always has to be positive.
So when you asked that question earlier, which one's positive? It was actually
The radius is positive 100% of the time. It always is. So even with arc side, where I was saying, which one's always positive is the horizontal, the radius is always positive 100% of the time. Spencer?
You don't even have to consider the plus or minus.
For a radius, never. Now, if you had to find either one of the other ones, like if I would have given you arc cosine up here, you'd have to have a plus or minus in there because you couldn't necessarily determine it for sure because it's an x. It's not a number. The only way you could get around that, though, is that we determine that it's for arc sine, the horizontal is always going to be positive. The arc cosine, the horizontal is always going to be positive. But then it just depends on if the arc sine is inside or outside. But we'll talk about that, I'm sure, when the homework questions come up on Tuesday. So that's not our final answer. What's the cosine of that angle? The cosine is the adjacent over that. So our cosine is equal to 1 over the square root of 1 plus 9x squared. Yay, right? No, we're not done yet. What do we have to do? Yeah, you have to square. How do you get rid of that square root? Multiply the top and the bottom by the square root. Yay. Doesn't it feel gratifying to know that? Yeah, it's ugly. It's not the funnest thing we'll do this year, but yet it is what it is, and there is what it is. All right, other questions before we pour some more homework on you because thank you, fun work, yes. Because somebody tried to tell me last night that if school's canceled, that you can't do homework. It's like illegal. Good news though, you don't have homework in this class. You have what? Fun work, and fun is never illegal. You heard they out. What's that? Hannah, like what? That was a really high-pitched dom, too. Okay, let's give you some. Let's go for, again, we're on page 473. We're in section 5.6. We're done with chapter 5, then we'll do 6.1 when you come back on Tuesday. You have to do the vocab check. You have to do 2 and 3, the 2 you didn't do last time. You have to do number 12, problem number 12. And then we go for 20. I did not give you any of the 20s, correct, last time? Okay, 19 through 25, the odds. Yeah, and then 41 through 53, the odds. You did 45? Okay, you already did 45? So you don't have to do 45 again. And then let's go for 64. And are you okay? I don't either. It's a Pastorello effect on people. Say 85. Problems. Because the first part's just that vocab check. They're not problems. They're just like, do you know? And you are always welcome to take a picture of it as you're walking out. That's probably the fastest way to make sure you have it.
Well, you will send it out before Monday night at 11 o'clock.
What's that?
You will send it out before Monday night at 11 o'clock.
We'll see.
Or Tuesday morning for period.
No problems. No promises. No promises.
Well, then no
Kind of
promises.
forgot that website.
Yeah, I just, yeah. Just Google Lynn McMullen.
Okay.
Lynn McMullen calculus, and it'll take you to his site. Then click on publications. He publishes lots of books. He writes the AP test.
Okay, thank you.
Yep. Who do I need to talk to? Kaylee Todd. I'm just worried. How are you going to feel if Cameron wins an award and you don't?
I don't care.
You don't care. So if Cameron comes home, bragging, all excited,
I
and
don't
said,
know things than I am.
you're going to let him get away with that? I'm worried about next year's scholarship apps, and if there's like 45 lines and you only have 44 things, is he going
Another 4.
Happy weekend, everyone. Drive safe. Good driving. It's slick out. The worst month of your life.
If you're an animal, you'd be a turtle because you're really slow, but you always run a race. That was the worst. Have you seen her do an assignment? I mean, they were trying to go, but she takes her time, but she always gives a final, and so then it's like, not in the final.
Especially when you have to do a refinal.
Yeah.
Yeah.
And I was gonna repeat that test, and I just.
I don't blame you. I mean, this is my own idea.
I was dead, and it was a whole week of like not sleeping. I was just like, yeah, you. Probably the worst month of my life. It was my worst math. Actually, no. It was
Yeah, so this is like, that's super pretty.
I don't know. I haven't even talked to her.
Oh, yeah. Seriously.
Not on 6.
I use 6
quickly, but we have Apple.
$1,500.
Everybody will have a $1,500.
No way ever in that.
Yeah, so this is my.
Please remove all the time.
I've got
I'll just,
Are you sure?
100% sure, I don't want to miss that one. I really don't. Well, my parents have a nice new one, but no, I'm not.
You know, well, I wouldn't bring a nice new one, just so you know, though, I'm not joking with you. Everybody will have a really nice laptop.
Everyone in extemp?
Yeah, for extemp, because so extemp, here's how it works. So they will give you 3 questions, and then you have a few seconds to choose which one of those 3 you want.
Yeah,
Then what you do is you go back and you have 30 minutes to write a 7-minute speech.
Yep.
Now, more than likely, you may not know everything about it.
No.
So how do you get information on it?
You can't look it up.
Yes, you can.